Okay, that's the question 20. Methane was burned in an incorrectly adjusted burner, and then you get carbon monoxide and carbon dioxide. So methane, all right, I'm going to write two equations. First one is to give you carbon dioxide, and the second one is to give you carbon monoxide. All right, so if I try to balance it nicely, this will be 2, this will be 2. Okay, if I try to put 2 here, but this will be 1.5. Okay, this will be 1.5. So if they mentioned that the carbon dioxide and carbon monoxide in the ratio is 95:5, and amount of methane used is xdm cube, what will be the volume of oxygen consumed? So I'm pretty sure that this one should be 0.95x, okay, dm cube, and this will be 0.05x. Okay, so the why I do that, because methane and carbon dioxide is 1:1, methane and carbon dioxide 1:1. So if I work backwards, I can see that actually originally I used 0.95x dm cube of methane over here. You can see 1:1, and here since it's also 1:1, right, so the amount of methane here is also 0.05x dm cube. Okay, add them together. This must be so this is actually going to be x dm cube, isn't it? Okay, this will be x dm cube. That's how I could see it. Right, so let's check. Okay, so the amount of oxygen, all right, the amount of oxygen used here, it may be double of this. Okay, so it's going to be 2 times of 0.95x, all right, and then over here plus 3/2 times 0.05x. All right, so this is the volume of oxygen. Okay, volume of oxygen. So let's try to get the way the answer wants, right? So I'm going to change this one here to x minus 0.05. Okay, x plus 3/2 0.05x. So this will give you 2x, okay, minus 0.05x plus 1.5 0.05x. So you press off, if you look at it carefully, this will give you 2x. So minus 2 plus half, 1.5 is left minus half, right? Minus half 0.05x. You see that? So based on what I just showed you, in fact this one is option C. Okay, so that's how we do it. All right, so that you need a bit of manipulation at the end.